Stephanie Garcia. And then let's see, Alejandro's here. I'm just trying to keep up with my attendance as much as possible just to make everything easier. So I'll make sure I'll revisit the attendance at some point. And anyone that I don't have a check mark for, I'll probably call out their name unless I can get them down quick enough so it doesn't take too much time in class. So I just saw somebody else pop in, but I'm going to let that go for right now. So the first thing I want to talk about today is some announcements. So I want to show the conversation so I can see it. So I'm going to do that first. And I really want to talk about some standards across the country in terms of colleges and universities. And we do have standards because we want classes to transfer from one institution to the other. And so if, say, when you pass college algebra, if you pass college algebra, and I hope all of you do, if they put you in the next math class, you want to be able to handle that next math class. So it's important to have standards across the country and around the world. I can't speak for around the world, but I can tell you that I have taught in Ohio, I have taught in Arizona, and now I teach in Arkansas. So I've been kind of different places in the country, and the standards are pretty much the same across the country. Not to mention, I went to college in Minnesota and my husband went to college in Massachusetts. So we've got the country pretty well covered with, our being in college and graduate school both, and then teaching when we left graduate school. So that's what I want to talk about today. To start off with is some of those standards that we have and why we have them. Hayden, I got you down for attendance. So one of the standards that we have is about how much time should you be spending outside class for each hour you spend in class, and how many hours per week should you spend outside of class for each hour in class. And this is pretty standard across the country. So the weekly expectation in college courses across the country is to spend 3 hours outside of class for each hour in class. So we meet about 2 hours twice a week. That's 4 hours times 3 is 12 hours. So that is just a guideline that you should be spending 12 hours outside of class a week, just approximately. Now, if you came into class in a really strong position, you may get away with less. If you came into the class in a weak position, you may have to spend more. So that's just a guideline to give you some idea of how to budget your time for the week. And I understand that we're all so busy. I feel overworked, to be honest with you, because I've got 2 daughters I have to help virtually, and my husband's working virtually from home, and so we have got to balance all of that. And so it's really challenging. I realize that, but we can't change what we cover in this course because of the standards that we need to have across the country. And before a school, if you want to transfer to, say, a school in Texas, they may ask you to give them a copy of the course syllabus, and then also look at your grade for the course and deciding whether to give you credit for it at their institution or whether they want you to retake the course. So there are definite standards, and I wanted to make you all aware of that because I'm not sure if you're all aware of that. And those are what the guidelines are for the expectations for how many hours outside of class you should be spending on this course per week. And I understand, we've got jobs, we've got to take care of our children, our families, and so forth. We may have older parents we have to take care of. I understand all of that, but at the same time, we can't reduce our standards. Because that wouldn't be fair to you or if I did that. And I can't do it. I have standards that I have to keep for the Arkansas Department of Higher Education. They also have course outcomes that they want to make sure we cover so that this course transfers to University of Arkansas or other states or other institutions around our state and in neighboring states and so forth. So I really can't do anything with what we're covering in this course. And we're covering in this course what, in this college algebra with review course, what the college algebra courses cover too. And so we're doing the same topics really. So with that in mind, I realized that, and I haven't done this yet, but I've decided to do it this time. I've never given a retake in a remote course, but I'm going to do it this time. However, there are going to be certain you're going to have to meet a requirement to be eligible for a retake for test one. I do not have the test graded yet because I'm giving tests and having to support them and all the questions that go with that. And I am still giving tests. I'm giving tests to, let's see, tomorrow, and my 2 online classes are taking them tomorrow and Saturday. So I will be grading some over the weekend, but I think you all have a pretty good idea of how you did on test one. So here's what you will need to do to take a retake. I am offering a test one retake. This is the one and only test retake that will be offered this semester. I will not offer any more. By then you will know what I expect, and you will hopefully find out how important this assignment is that we're going to talk about. In order to qualify to take this retake, you are required to get a score of 85% or above on the test one review no credit assignment. Over the last several years that I've been teaching with Alex, students who do these assignments generally do very well in the course. The major issue with the objectives is you've got all those learning aids there and so forth, but on a test, you're not going to have those learning aids. So you want to make the leap from the objectives to the test. So that's what this test one review no credit assignment is designed to do. So this assignment, this test one review no credit assignment, is active right now. And this assignment will disappear on Tuesday, 2/16 at 12 p.m. just in time for class on Tuesday. So it's going to disappear right before our class this coming Tuesday. I will meet with students who qualify to retake test one near the end of the class this Tuesday. So those that qualify to take test one, I will talk to you the last few minutes of our class, and so that you can decide when to take the retake. And I would encourage you to take the retake, just to put a bug in your ear, to take that retake on Tuesday evening or Wednesday mornings. I'm not teaching class at those times, so I can support you at any questions you have. However, you've already taken the one test in this class and you've seen what you need to do with those steps before the test, immediately before the test, and so forth. So, it's up to you, but just realize the risk you're taking is I'm not going to be there to support you unless you take it Tuesday night or Wednesday morning. And I want one window that will cover everybody. So that's what I'm looking at now. And I'm also looking at the fact that you're going to have an objective due this Sunday, and this is going to be due on Tuesday. And then you're going to have another objective due on Thursday of next week. I'm trying to space it out. So probably, if you can, Tuesday evening would be the best time to take that retake. So the objective that we will be covering today is due this Sunday, 2/14. So you've got an objective that's due tonight, an objective that's due Thursday, and the test review no credit assignment is due on let me make sure I said that right. We've got an objective due tonight, which is Thursday. We've got one due on Sunday, and then we've got this that's due on Tuesday. I'm trying to space it out. But at the same time, I don't want it to be too far in the future that you're going to, then there's more likelihood you're going to forget what the material on test one. Test 1 is the easiest test in the entire course, so you want to make sure you knock that one out of the park. And that's why I'm offering a retake. So I've also want to talk about a couple more things with you. Let's go into Canvas for a moment. I want to take a look at the syllabus for this course. And it's available when you enter Canvas on the left side. The syllabus is a contract between instructor and student. And I'm going to pull this up, and I really want to look at how the grade is determined in this course. So right there, and let's see, I'm hoping that I can make it bigger. Let me see if I can download it to my desktop and it will make it bigger. Let's do that. Okay, so right here is where I want to look. And can you all see that the syllabus? I'm just making sure if I've got everything on that I need to get on. And let me make let's do that. So the grading, sometimes it does it. The grading in this course. So let's talk about this. 90% and above is an A. 80 to 89.4% is a B. That's because I round up if you're close enough, and so forth. What I want to show you, I want to look at the test. So there's regular exams. Those are the first 3 tests. Those are 50% of your grade. Those are half of your grade in this course. The comprehensive final is 18% for the major part of the final, and then there's a Canvas quiz part that's worth 2%. So that's worth 20%. So the exams are 50% plus 20%, which is 70% of this course. The remaining 30% in the course is unproctored work, which includes this Start Here Canvas announcement, objective completion, participation, and some homework in Alex that you will be doing near the end of the semester. So this bit here, the non-exam part, is only 30% of the grade. That's standard in college courses across the country. In fact, some institutions don't even allow 30% proctored work. They allow maybe 25% or less of proctored work. And some faculty across the country make everything based on proctored work. So at NWAC, we are only allowed by departmental policy to give students up to 30% unproctored work, and I'm at the maximum. What this means for the tests are 70% of the grade. Now, that means you've got 30 plus 30, which is 60, plus another 10, which is 70. So the tests are worth more than twice as much of this work up here. So the tests are really important to focus on, extremely important. So this is pretty standard across the country, how the grading system works in colleges and universities. So what I'm trying to say is you really need to focus on the tests because they're going to determine really whether you pass the class or not. They're worth 70% of the grade, the tests are. And that's more than twice as much of the twice as much as the unproctored work, which are the objectives, the assignments. That's a homework assignment in Alex, the participation. So and you should get all of those unproctored points if you can, because that's going to help you to hopefully pass the course. I want you to focus on the test. I mean, it's a leap from the homework and the objectives here to the test. And that's why that test 1 review no credit assignment is so important, because it acts as a transition. You really want to study for retention and really that means you want to study as you go a little bit. You want to study some every day. You don't want to wait until the night before, the night something's due to work on it, because that usually you're just doing the assignments. And I've been there myself. I've done that too. And I find that I'm doing the assignments to get them done, and I don't remember what I'm doing when I've done that. I don't remember as well what I'm doing. And so you want to make sure you're remembering well what you're doing through the course, because you're going to have a comprehensive final, which is required by departmental policy, and that final has to be worth at least 20% of the grade. So these two parts together are worth 20%. So I'm at the bottom of what I can give you. Other instructors make their finals worth more. So at NWAC, so I'm at the bottom of what I could give you for everything that really I had the wiggle room that I have. So I just want to let you know, it's really, tests are very important, and they're weighted heavily in colleges and universities. So any questions on that so far? And I'm doing this to help you out, because I want to, this test one review, no credit assignment, you really want to do well on that, get that 85% or above. And the reason why it's 85% or above is because every topic on test one is in that assignment. And if you don't get at least 85% on that assignment, you're not going to likely, are you going to really pass the test then when you take the retake? And I'm looking for you to pass the test. You can take that test one review, no credit assignment, as many times as you wish. The first 7 questions in that assignment are going to be still the written work required problems.
I have a question about the retake.
Yes.
Is it gonna like cancel out our other score, or is it like, how is the scoring gonna work?
I will count the highest of the 2 scores.
Okay, sweet.
Any other questions about the retake? So I hope that you all take advantage of the retake. I haven't ever done this really, but I will do it here, because I really believe that, this is a different time we're living in. We're using, I think, different placement measures of students in math courses and so forth, because we're having to adjust because of the pandemic. So I've decided to give you just a retake for test 1. I am not going to do it for test 2, test 3, or the comprehensive final. So I'm just giving you a second chance here because of the current environment in our country. So I think I've covered everything I wanted to cover to get started, except I do remember that I want to go into Alex here for just a moment. So let's go into Alex. And I want to take a look at right here. This is the screen that came up in Alex today when I went into the student view in your class, the Tuesday, Thursday class. You can see it up here. And you can see you've got test 1 review, no credit. It's due Tuesday at 12 p.m., just in time from class. It has 25 questions. So of those 25 questions, the written work required topics will be exactly the same, but you're going to get different questions. And then that's 7 of questions, and the other 10 will be those 7 questions are selected from this assignment. They will be the first 7 questions in this assignment. And then the other 10 topics will be questions from this assignment. So everything's in this assignment that you need to prepare for the test. You've got learning aids. You've got learning aids over here. If I click on one of these, just a random one, I've clicked on 5. You've got an explanation page here. You've got a example page here. You still have you've got those learning aids there for you. And if those learning aids don't work for you, remember, we've got those videos from before. There is one on specific, I think there's an announcement, right? There's a Canvas announcement that has some videos has a video for each one of those written work required topics. So you've got a lot of resources. You've also got the video library that we have for all of the videos that I've created in this class. There's links to those in Canvas, and if you're interested, shoot me an email. So there's a lot of resources for you all. So let's get started on today's objective, unless anybody has another question or two about the retake. I will let you know as soon as those tests are graded. I'm planning on grading the first test ones this weekend. I will let you know as soon as they are graded. So I think y'all have a pretty good idea of how you did on the test. I've taken a peek at it myself, which is why I want to be sure to offer the retake here. But in the future, I will not offer retakes. This is the one and only retake you will have for sure in this class throughout the semester. So our objective that we are looking at today is more on functions. So let's take a look at that. Go down to my desktop. And I have one topic that I had moved from the previous objective to this one that's due on Sunday. We need to take a look at this one. It is finding inputs and outputs of a function from its graph. And let me make sure we've got to see it all as big as possible. So let's take a look here. And the key to such a problem is really finding the important ordered pairs. So the graph of a function g is shown below. Find g of 1. What's inside the parentheses is the x coordinate. This g or h or f or that letter out in front really means the y coordinate. You see a letter here out in front, that means the y coordinate. So what this is saying is find the y coordinate when x is 1. And find one value of x for which all of this together on this side is the y coordinate. All of it together is the y coordinate. G of x is the y coordinate at a particular x. So here we want to find one value of x for which g of x equals -2. This whole thing is the y. Over here, let me make, so this whole thing is the y, so they want the whole thing, this y here to be equal to -2. They want all of this the y be equal to -2, and they're asking for one of the x's, one value. They're asking for one of the x's, which makes y, this whole thing, equal to -2. So let's take a look. Let's first look to see where x is equal to 1. So on this graph, 1 is right here. It's right here. 1, 2, 3. You might not be able to see it clearly, but 1 is right there. So when I'm looking for 1, I want to find a point on the graph that has a x coordinate of 1. So I go from 1, I go and look where my graph is. It's above the x-axis, so I go up until I hit a point on the graph, and the x coordinate of that point is 1. And I can check it by taking this point and going back down to the x-axis to see what its x coordinate is, and it is 1. Now we want to find the y coordinate. So we can take the point, this high point here, up here, take this high point up here, and to get its y coordinate, we go straight over to the y-axis, and it's at 2. So the ordered pair is 1, 2, the x coordinate, the y coordinate. Any questions on how I got the ordered pair 1, 2? And so what does that mean about g of 1? The whole thing is y. They want us to find the y coordinate when x is 1. X is 1 here, and the y coordinate is 2. So the answer over here for g of 1 is 2. So we found what is the y, we found the y coordinate associated with x equals 1. And now, any questions, please interrupt me. Don't hesitate. It's your class. It's you who are learning it. You know what you need more than I do. So if you have questions, please ask. And no question, I don't care what questions you ask. I want to help you do better. That's my goal. And so it doesn't matter what those questions are, in the sense of whether I look at them as, I don't think of students' names with what the questions they ask. I never did in the classroom. And so, doing class remotely, I can't really do that even. It's much harder to do that. And I'm just not me. It's not me to do that. I'm here to help you. So let's go back here and look for one value of x for which g of x, the whole thing, which is y, is equal to -2. So g of x is all of this. That means this side is y equals -2. X is the unknown. So we're looking for y equals -2. Where is y equal to -2? So we're going to go to the y-axis. -2 is right down here. And you will see, it's hard to see, but there's a point right at -2 on the y-axis. And if we even go over more, we start at -2 on the y-axis, we can go over to another point here. So there are actually 2 points on our graph that have a y coordinate of -2. There's one right here on the y-axis. There's one straight over here as well. We just need to figure out what those are. You could pick either one. Alex is asking for only one of them. So you could pick this one on the y-axis. This would be at -2, because that's what they gave us, right? -2. And to get the x coordinate this time, we go straight up to the x-axis, and that will actually be at 0. So the x coordinate is 0, the y coordinate is -2 of this point right here. Over here, this point right here also has a y coordinate of -2, because you can trace it over to the y-axis and you will get to -2. But what's its x coordinate? Well, we go straight up to the x-axis to get the x coordinate, and it's at 3, the x coordinate. So whatever one of these you want, you can pick one of them, because they're only asking for one value of x. You can either put in 0, or you can put in 3. I put in 3. Alex would have accepted 0 as well. Any questions on this particular topic? Well, I'm going to cross that off my list. So let's go into Alex to do a topic. I want to go into Alex to do a topic. Let's see. We're in Alex here. And I'm going to save this for later, because I want to go and work on an objective. So if you want to, you can take a break and save this for later, go work on some topics in an objective that's due, say, Sunday tonight, and you can take a break there. You can, when you're all done with the assignment, you want to submit the assignment, and you have question attempt 1 of unlimited. You have an unlimited number of attempts, so you can take this over and over again by just starting it over. You can click on, I believe, start to do so. It's very clear in Alex how you can start it over. So you can take it as many times as you want. I will count your highest score. So I'm going to go into Alex. I'm going to save this for later. This assignment was saved successfully. Just so in case you don't always have on the Pi page a clear way to get to that assignment, you can go to the 3 horizontal bars, click on those, go to the main menu, go down to assignments, and then you will see that particular test 1 review no credit assignment, and it says in progress. So you can get there directly just by going to assignments on the main menu. So let's go to learn mode and review mode. Well, I've got them both active. So what I'm going to need to do is get out of here, go back into Alex and reset the student view because I want to make sure that I have all topics available. And let's do that. It shouldn't take too long to reset it. I have to go through a few things to do it, but it's really the best way to show you what we need to do today. So we're the Tuesday, Thursday class. And I want to go into the student view. 58 topics, that's good. Enter student view. And it's probably gonna, oops. I forgot to do something. I totally forgot to do something. I need to reset the student view. Okay, so it's gonna take me through these pre-steps here. I'm just gonna go through them as fast as I possibly can. Skip tutorial. Not going to take the knowledge check. I'm going to get through that as fast as possible. Guess they're going to make me start it, but I'm not going to take it. Skip knowledge check. We want a complete knowledge of college algebra because that'll put all the topics in the review part of Alex, which is on the main menu. And I want to go to the 3 bars. I want to go to review mode. And we are seeing the pop-up there. And I want to go click on more on functions. Got to start this before it'll give me the options of what I can click on up here. Let's click on this. And now I want to go to more on functions. What I'm looking for is domain of a rational function excluded values. Right here. Start. So what we want to do here, do you have a question?
Is this the objective that's due tonight? This one right here?
No, this one is due Sunday.
Oh, okay.
Okay. Let me see. Let me see. I don't think you have one due tonight because of the test. That brings up a good point. Let me just see on that. Let's see what's due tonight. Oh, let me go into, got to think of the safest place to go in here. Let me go and find assignments to see when this is due, the objective. Or I think maybe even a safer place, because I don't want to show any grades. I think a safer place would be class summary. Let's do that. And over here, PDF. Thank you for bringing that up, by the way. So I'm just going through this, which lists all the different objectives. So you've all already done the test 1 review objective, correct? You've already turned that in? I think you have, because it was before the test. So Let me tell you. That
I
was
don't know.
that was due on 2/7. Yep. So you've already done the test one review objective. That was due on 2/7. And so more on functions is due 2/14. So you don't have anything due tonight.
Oh,
Okay. I misspoke about that.
so we have to do the test credit no review for the retake, right?
Yes. Yes. So this is perfect time for you to work on that because you don't have anything due on Sunday.
Oh,
Now,
okay.
no objectives are due on Sunday. Let me just double check once again. So we're talking about the test one review objective was due 2/7. Well, this isn't 2/7. This is 2/11. Then the next objective here, this is all test review, more on functions is due 2/14, which is Sunday. So you only have an objective due this Sunday. That's the next objective. There is not one due tonight. So it's a great time for you to work on the test one review, no credit assignment. So you don't get too far removed from the test. Everybody good with that?
Yep.
Thank you for asking about that. So let's go back to, we need to go back to Alex, and we may have to, I hope we don't have to log in there again, but why don't, let's see if we can, there, cool. So we want to look at domain of a rational function excluded values. And we will go down to the whiteboard to do so. So let me copy this function down. And what do we want to do? We want to find all values of x that are not in the domain of H. Well, first of all, what is a domain? Let's just go define what a domain is. You get a new document. Let me change the layout of it to orientation. And let's draw on this document. So we're talking about domains today. We're going to talk about ranges too. Domain. A domain is a set of all x's. It's all the x's, all x's. All x's. A range, on the other hand, which we'll also be talking about today, is all the y's. And this, when we talk, so when we want to find the domain, we want to collect all the x coordinates of all points on our graph. So we're looking to collect those x coordinates, and we want all of them. When we're looking to find the range, we want to collect all the y coordinates from all the points on our graphs. So that's what we're looking for here. Now, in this particular problem, which let me copy that down, we've got h of x equals x squared plus 3x minus 54 over x squared minus x minus 2. All we want to do here, though, this is a little bit different. It's still talking about the domain, but it's talking about it in sort of a negative way. Find all values of x that are not in the domain of H. Find all values of x that are not in the domain of H. So if we go down here, and I'm going to write down what H is, H of x, our function, is equal to x squared plus 3x minus 54 divided by, it's a rational function because we have we have a variable in the denominator, over x squared minus x minus 2. So what you'll notice here is we're looking for values of x which are not in the domain. Sometimes we state it positively if it's suits our purposes. Sometimes we just look for what's not in the domain and we exclude those values. And that's what this problem is wanting us to do. Find the excluded values of x. In other words, for which x's is this function not going to make sense? And what we're seeing here is a 2x, we're seeing an x in the denominator. What number can we not divide by? What number do we not want the whole denominator to be equal to? What number causes us a problem when we divide by it?
0.
Exactly, 0. So to find the excluded values, we're just going to take the entire denominator and set it equal to 0. And then we're going to solve. Now, one way you could do that is by the quadratic formula. So we want to solve that equation. So let's use the quadratic formula. So we're going to have x equals negative b. B is this negative sign here. So this is A, B, and this is C over here. So B is, so we, in the formula, it's negative, and then it's B, but B here is this negative sign, which is negative 1. So negative 1 plus or minus B, which is negative 1, plus or minus square root of B, which is negative 1, plus or minus the square root of B squared, minus 4AC minus 4. Our A is an understood leading coefficient of 1, so we don't have to write it in. And C, it's minus 4AC, so C is negative 2. All over 2A. A is just an understood 1, so we don't have to write it in. 2 times 1 is 2. So what we want to do now is see what's in that square root. So I'll just put that over here. Negative 1 times negative 1 is positive 1. And then we've got this plus a negative 4 times a negative 2, which is a positive 8. So this is going to give us a square root of 9, which is 3. So now we need to find our two solutions. We're well on our way because we've got here x right here. So x is equal to negative of a negative 1, which is 1, plus or minus this 3 over this 2. So we're going to have to break these down into two. We're going to get two separate numbers where we use just the plus sign, and then another number where we use just the minus sign. So we have 1 plus 3, which is 4, divided by 2. 4 divided by 2 is 2. And the other number that we are going to get is 1 minus 3, which is negative 2 over 2, which is negative 1. So those are our two excluded values. Those are the two numbers that will cause division by 0. And you can check them. Quick checks are nice. If I put 2 up here, you get 2 squared, which is 4, minus 2. 4 minus 2 would be 2, minus this 2 is 0. So you can check those. So we get 2 and negative 1 as our excluded values. Does anyone have any questions on this? So let's go back up to Alex and see if it's waiting for us to enter some answers. If there's more than one value, separate with commas. So we've got 2, comma, negative 1. Check. Any questions on that topic? So let's go back to my desktop now and resume with this right here. I'm going to look at this objective. And I want to work with the rational functions first, and then we'll come back and work with the square roots. So what we just did when we had a rational function is we just found the numbers that cause division by 0, and we stated those. Sometimes when we have a rational function, we're just looking for the values that are excluded. Sometimes we want the domain where we include all numbers. So let's talk about that now. And there's two parts to this one. Domain of a rational function, and a rational function just has, it's really the quotient of two polynomials is what it is. So that's why we see two polynomial-like function expressions, one in the numerator and one in the denominator for both of these. So we're going to do them one at a time. So it's just going to be a step up from what we just did. So what we're going to do is we're going to divide by division by 0 is undefined. So we want to set the denominator equal to 0, just like we just did. This problem is a twist on the other one because we are going to exclude those values, but we're going to also use interval notation. So we're just adding another step. So we want to set the denominator equal to 0. That's x squared plus 3x minus 40. Set it equal to 0 right here. And then we want to factor. Well, this factors, I'm not going to spend time on factoring because we've spent a lot of time on factoring already in this course. So this just factors into x plus 8 times x minus 5. And you can check it, x squared, check. And then that's minus 5x plus 8x is plus 3x, and then minus 40. Or you could use the quadratic formula to find these numbers here that you want to exclude, just like we did in the last problem that I did on the whiteboard. So we set x plus 8 equal to 0. We move the 8 to the other side. When we do that, we get x equals negative 8. We set x minus 5 equal to 0. When we move that minus 5 to the other side, it goes over as a plus 5 on the other side. And that's what we are doing. So what causes division by 0 is negative 8 and 5. We want to throw those guys out. We want to throw them out. So we're going to make a graph on a number line to throw them out. So over here on the number line, we have negative infinity. Over here, we have positive infinity. -8, we want to plot on the number line relative to 5 in the correct order. And we draw a circle here, indicating, since there's no black in here with the pencil, that means it's not included. And then we do the same for 5. 5 is to the right of -8 on the number line. So we put a circle here. Circles are just the border. So we throw them out. Now the question is, how do we write with interval notation? So let me just back up a little bit. You might want to copy this down. This is a little way I present how to know when you use parentheses versus brackets. So these are parentheses here. These are brackets. So it's easier for me to remember when to use a bracket, and then all other times I use a parenthesis. So the only time you use brackets is if an endpoint is included. In other words, you have a colored in, you have a circle which is colored in. Or you have greater than or equal to or less than or equal to in the problem somewhere. So this is a way to remember how to use interval notation throughout the entire course. I remember that brackets, that's when the endpoint is included. And one way of showing that is you have a colored in circle. You have the and greater than or equal to, you've got the equal part, so you want to color in that circle. Less than or equal to, you've got the equal part, so you want to color in that circle. So that's how I remember. I look out for this colored in, one of these that I'm dealing with, and that is how the clues that I use to tell me that I've got a bracket. All other times we've got a parenthesis. Negative infinity and positive infinity, there's never an endpoint because they go on forever. So they get a parenthesis. You use parentheses when the endpoint's not included over here. And when you have an open circle, well, circles are just the border. So when you've got a circle only, or when you've got an inequality symbol that's like this or like that. I prefer to remember less here, and then just to know that all other cases I use parentheses. So let's go back to our problem here that we were working on. We want to take what we've got here and write it in interval notation. So we're actually writing our domain. In other words, the set of all x's for which the function makes sense. And that means we have to throw out these two. So we always write interval notation from left to right. So D for domain equals. We're starting here at negative infinity. That's not an endpoint, so it gets a parenthesis. Negative infinity. This comma in between means all numbers from negative infinity, all the numbers between negative infinity and -8. We don't want -8, the endpoint's not included, so we use a parenthesis. We use a union symbol because that's just standard in math. That means we want a number in this interval, or this interval, or this interval. So we use a union, U for union, and then we start up again a hair after -8. So I put -8 here. -8 is not included. That endpoint is not there. It's not included, so we don't include the endpoint since it's not included, so we use a parenthesis. Then we want -8, all the numbers in between -8 and 5. This endpoint is not included, so we use a parenthesis. Then we want to have another set of parentheses or another part of our domain stated, so we want to use another U for union. We start up a hair past 5, but it's 5 is not included, so we use a parenthesis. We want all the numbers from 5, not including 5, all the way to positive infinity. Anybody have any questions on how I did that? So Alex will have you draw that. You will plot these circles first, and then you will have a tool that will allow you to click on what parts of the number line you wish. Any questions on that?
No.
Okay, good. Thank you for your feedback. All right, let's move down to this one. This is a quirky one. G of x equals x divided by x squared plus 81. For each function, find a domain. So we're looking for all the x's for which it makes sense. And they're even reminding you and Alex to use a union. So U for union symbol. So that's nice. So we're just going to do the same thing. We're going to take the denominator and set it equal to 0. So I copied the function down here. You want to take the denominator, x squared plus 81, and set it equal to 0. And we want to solve for x. So this is supposed to be a plus 81 here. The opposite of adding is subtracting. Let's subtract 81 from both sides. That will give us x squared here. This is positive 81 minus 81 is 0. So there's going to be no more contribution on this side. Equals 0 plus negative 81 on this side. So that will just give us negative 81 on this side. Whoops. So what we're looking to do is to solve this equation, and we notice we have an x squared. The opposite of squaring is square rooting. So we're going to take the square root of both sides and put the plus or minus with the side that does not contain the variable x. So square rooting undoes squaring. So on this side, we just get x equals plus or minus. Now this is a negative. It's really a negative 1 here. Negative 1 times 81. The square root of a negative 1 is I, the imaginary unit. The square root of 81 is 9. This imaginary unit tells me that we do not have a real number. Positive 9i and negative 9i are not real numbers. They're complex numbers which are not real. And in this graphing context, we are only talking about real numbers. So there are no numbers that we need to throw out because we're only working in the real number system. So if we throw these out, these numbers are not real. We can't throw them out in the real number system because they're not real numbers. So the domain is all real numbers because we didn't find any real numbers at all that caused division by 0. We only found complex numbers that are not real. Any questions on here? So we want everything. We're only concerned about the real numbers that we have to throw out in this context because we're graphing. And therefore, we found no real numbers that we have to throw out. So we want everything on the number line, on the real number line. We want everything on the real number line from negative infinity to positive infinity. And the way we would write that down for the domain, that is the set of all real numbers for which the function makes sense, is we'd start at negative infinity, which is not an endpoint, it's a concept. So we use parentheses. Negative infinity, we want all the numbers from negative infinity, all the numbers in between, that's what this comma represents, all the way to positive infinity, which is right here. And that is not an endpoint, it goes on forever. So we use a parenthesis. So the domain we write is parenthesis, negative infinity, comma, infinity, parenthesis for this part. Any questions on this? So I think we're good with this problem. And let me check that one off the list. And let's talk about square roots, domain of a square root function. I'm going to back up a little to do so. So domain of a square root function and advanced. So we've already looked at graphing a square root function, so I think this will be okay for us. Find the domain of the function v of x equals square root of 8 minus 2x. What's inside the square root here is called the radicand. It's just terminology. Now, what we really want to look at here is the domain. We're finding the domain. A domain in general is the set of all x's for which the function makes sense. And then range is a set of all y's for which the function makes sense. But we're only talking about the domain here. So we cannot take the square root of negative numbers. Not in the real number system. If I want to take the square root of a negative number, say the square root of -1. That's I. We're only working when we're talking about domains, we're talking about it in the context of graphing. Okay, so the square root of -1 is I. So we can't be taking the square root of negative numbers, because every time we do, we'll have a negative and we could write it as a -1, and when we take the square root of that part of it, we're going to get an I. So my point is, you can take the square root of 0, because if we do that, what we really have to have is 2 zeros inside to take it out as a single one. And I think I might run out of room here. Let me back that up a little bit. I really want you to see this. I think what I'm going to do is I'm going to write it down for us. So this was an I. I don't want us to forget that. Now, this software is so fun sometimes. I just got to deal with it, though. Since it's free, that's an I. Now down here, if I rewrite the square root as 0 times 0, square root of 0 times 0, there's no harm in doing that. That is indeed equal to the square root of 0. 0 times 0 is 0. So what's inside the square root here is exactly what's represented here. So for these 2 zeros, I can take these 2 zeros out front as a single 0. So this is really just equal to 0. So the square root of 0 is 0. So we can take the square root of 0. And we can take the square root of any positive number. So what we want to do is take right here, what's inside the square root. We can take the square root of numbers inside this right here in this radicand, as long as they are 0 or positive. And to be clear, let me write down, you can also do it for a positive number. You do it for 0 or a positive number. Those are the kinds of numbers that we can take the square root of. So we take what's inside the square root, we copy it down here. That's what I did here. And then we know we need a positive number. So whatever this is, this radicand, It's got to be bigger than. Positive numbers are bigger than. It's got to be bigger than. Positive numbers are bigger than 0. It's got to be bigger than 0. But it's also okay to have it equal 0. And that's what this top part of the equal sign right here is saying. It's also okay for that what's inside this is what's inside the square root to be equal to 0. So this is why we just call this the radicand. We copy it down, which is 8 minus 2x, and we want it to be positive, and it's okay as well for it to be 0. So we take 8 minus 2x, what's inside the square root, and we make it positive and 0 by writing in greater than here, bigger than 0, and equal to 0. And we just solve that inequality. Now, when you solve inequalities, if you multiply or divide by a negative number, you need to switch the direction. So I choose to avoid that as much as possible. So I don't think we're going to see that often in this course. Mostly, if we do see it, it's going to be minimal. And so I would look for a way to avoid multiplying or dividing by a negative number. So we want to solve for x. So I'm going to take this minus 2x and move it to the other side. And the opposite of subtracting is adding. So let's add 2x to both sides. That will give us just 8 on this side because minus 2x plus 2x is 0. So we get 8 greater than or equal to 0 plus 2x, which is 2x. Now we want to solve for x. And all we've done is added so far. We haven't multiplied or divided, let alone by a negative. So over here, we want to look at this 2x. We want to get rid of the 2. That's participating in multiplication. The opposite is dividing. But we're dividing by a positive number. And that does not switch the direction. Only a negative number. Positive number does not switch the direction. It will stay the same. 2 divided by 2 is 1 times x is x. And on this side, we get 8 divided by 2, which is 4. So we have 4 greater than or equal to x. When we work with a number line, we're working from left to right, smallest to largest, from negative infinity to positive infinity, smallest to largest. So let's write this inequality in the other way. As long as the big mouth opens to the 4, we're good. So let's put x here. Let's put the big mouth to the 4 on this side. And then we have to have our equal part too. So we want to graph x is less than or equal to 4. That means we want all the numbers on the number line, which are smaller than 4 and also equal to 4. So here's our number line. So if we start at negative infinity, we want all these numbers all the way to 4. And since we have the equal part of the inequality symbol right there, we want to include the endpoint 4 because we have the equal part. So if you remember, just going back here, we have an included endpoint this time. So we're going to use a bracket. We want that 4 because of the equal sign here. That's just the top part of the equal sign. So let's state this in interval notation. We're starting at negative infinity. It's not an endpoint, it's a concept, so we use a parenthesis. Negative infinity, we want all the numbers from negative infinity to 4. We want the 4 included because of the endpoint here and because of this equal sign there. So we're going to use a bracket in that case. Any questions on this particular topic? So you might want to, why don't I give you a couple minutes to copy this down when you use parentheses or brackets. I'm going to give you a couple minutes to copy it down because it is very important. And I don't think Alex describes it quite like that, where they have a column for parentheses and a column for brackets like that.
Question.
Sure.
When you graphed it, you showed that the 4 is included and
Yes.
the negative infinity isn't included. That being said, when it's set up, uh, x is less than or equal to 4. How? So only 4 could be the possible answer, and below, not below. So 4 and above, or how exactly is that working?
So I just give me a minute to address your question so that the students can finish copying it if they're copying it down, because I don't want to go off the page right now. Okay?
No
So
problem.
you could, yeah, Alejandro, if you could ask me the question again in a minute or two, then we'll look at that. So negative infinity is just a concept. It means going out forever and ever and ever and ever in that direction. And positive infinity means, so negative infinity means just going out. It's not a number. It's just a concept where you're going out forever and ever and ever and ever in the, on the left side of the number line. Okay? And then positive infinity is just a concept where you're going out forever, forever, forever and ever and ever and ever on the right side of the number line. They go forever and ever and ever. We put arrowheads on them to indicate they go forever and ever and ever. Does that make sense?
Yeah.
So did I answer your question?
Yeah, kinda.
Okay, just hold on. Does anybody need any more time to copy down what I've got on the screen at this moment? Okay, so let's go back to where we were talking about that. This is this is this one right here. So when we talk about number lines, we've got, let me just put in this one first out here. This is positive infinity. So negative infinity is just a concept that goes forever and ever and ever in the negative direction. I mean, somewhere in here is 0. I didn't really put it in here, but somewhere in here, let's say, it's not drawn to scale. Somewhere we're in here, we have a point which is 0. So negative infinity is a concept that just tells us we're going forever and ever and ever in the negative direction. So we use that to represent just forever in the negative direction. Positive infinity does the same thing. It's just a concept and it represents just going forever and ever in the positive direction. So this, because a number line is never ending. It goes forever in both directions. So we can't write out all the numbers on it. So we use negative infinity and positive infinity to indicate the going forever in each directions. We use the negative infinity because we're going forever in the negative direction. We use positive infinity to go forever in the positive direction, if that makes sense. So what we want here is we want all the numbers which are less than, that is smaller than 4, and also we want equal to 4. All the numbers would be all the way out, are all out, all the numbers all the way out to negative infinity, which goes forever and ever and ever, all the way to 4. And the 4 is included because this is the top part of the equal sign. It's not, you don't have to, with an equal sign, you have those 2 little lines, but we only have the top one here. Mathematicians sometimes are lazy, so we didn't write in both. If you want to think about it that way, that's just the top part of the equal sign. Does that help, Alejandro?
Yes. Another question. Why did you switch over the 4 in place of the x? Like, why did you switch them?
Because we always go from left to right on a number line.
Oh, okay.
So the X always has to be first?
Not necessarily. If you had a greater than, or if you had, let's say X, this turned out to be, let's say here we started with, instead of 4 greater than, we started with 4 less than or equal to X. And we would get a whole different problem. Okay, now this already 4 on this side is on the smallest side. This problem is different because this is 4 is less than or equal to X. We want that means 4 is the smallest that we could have. 4 is the smallest number that we can have because this is 4 less than or equal to X. So that's already written from smallest to largest. So we could just graph that on the number line like this. So if I had a little, I'm going to have a little number line here because I don't have a lot of room to put in a big one. So here's our number line. Now I'll get a different color. Negative infinity is out this way. Positive infinity is out this way. So that little part of the V tells you what, when it's like that or like this, that tells you this is the smallest number. This is X is smaller than or equal to 4. This is 4 is smaller than or equal to X. That's how it's read. So if I want to plot a 4 here, I'm going to have to get a different color so we can all see where it goes. And let me just get a different color here. So let's say blue. Oops. And I'm going to put a point here. It'll let me do it. I don't know what. Yeah, I need to do that little thing where that gives me that crazy little thing there. But I'm going to put a point here. That's where the 4 is. So it's somewhere in the middle of the number line. And then this says 4 is the smallest. 4 is less than or equal to. In other words, 4 is the smallest number we can have. Less than or equal to. That means we want it to be equal to 4. This part right here means we want it to be equal to 4. This little part here, this little line here means we want it to be equal to 4. That's why I colored it in blue. Okay, that's why I colored it in. And then that's the smallest we want, and we want all the x's after that. That's what that is saying. So we want all the x's after that. So we want all of these guys right here. And let me see if, yeah, it's crazy. We want all of these guys right here, all the way out to positive infinity. Does that help?
Yeah. One more question. How did you get the 0 from at the very beginning?
You mean here?
No. Like at the very, very beginning of the problem. Like where it's the square root. Yeah, there.
Okay. So those are the only numbers we can take the square root of. Positive numbers, and so what's inside here, this 8 minus 2x, whatever's inside the square root is called the radicand. The only numbers we can take, we're working in a real number system, so the only numbers we can take the square root of in the real number system are 0 and positive numbers. So I took what was inside here, and I have equals 0. So we can take the square root of 0. That's because we can take the square root of 0. And then this is saying, this is what's inside. This is saying we have to have those. That means bigger than. That symbol means bigger than. So we want all numbers bigger than 0, which we can take the square root of. And we also want this, it's okay for this to be 0 because we can take the square root of 0. Does that make sense?
Yes.
Okay, that's good. That's good. Well, we really need to go on. I wish I could spend more time on this, but I think it was good. Now, in this situation, I'm not going to spend too much time going over this because we did do another problem on the other screen. But here, this is the same topic, different question. You just want to take what's inside the square root and make it big. So what's inside the square root? It's negative x. And we're going to, because we're finding the domain here, we're looking for all the x's for which the function makes sense. So we're just going to look inside the square root here and make that bigger than or equal to 0, just like we did in the last problem, and solve this. So I will solve this a little bit for you because remember, we cannot, if we could, but it's harder to do it. We want to avoid division or multiplication by a negative number. So I would just move this negative x to the other side. The opposite of negative x is positive x. So we want to add x to both sides. That way you don't have to switch the direction of the inequality symbol. Now you might want to, like down here, but we don't have to switch it because of multiplying or dividing by 0. We're going to avoid that. So to avoid that, we're going to add x to both sides here. So we get minus x plus x is 0 on this side, greater than or equal to 0 plus x on this side. The reason why we did that is to get rid of that negative sign in front of the x. So if you multiply or divide by a negative sign, you have to switch the directions. Now this switching the direction here was done to graph it on a number line. It wasn't caused by dividing by 0 or multiplying. It wasn't caused by multiplying or dividing by a negative number. We switched the direction here, but we're switching it and keeping it the same, really. And we do that so we can graph on a number line from left to right. So if you notice, this big mouth opens to the 0 here. It still opens, that big mouth opens to the 0 here. So you can do that. And this little point is going to this little, let's look at this as a little point here, goes to the x, and that little point goes to the x here. So we, in some sense, you could say we switched it, but we didn't really, we only wrote it differently. We switched it in, we didn't switch the direction of the inequality symbol level. When you multiply or divide by a negative number, you have to switch the direction of the inequality. Here we did not switch the direction of the inequality, we just rewrote it. Instead of having x on this side, we have x on this side, but we didn't switch the direction of the inequality. The big mouth still opens to the 0 in both places. We just did it this way so we could graph it more easily on the number line. This is saying we want all the numbers which are smaller than 0 or equal to 0. So we want all the numbers all the way out from negative infinity till we get to 0. We want the 0 because that's the top piece of the equal sign. So we color this in. So now when we write interval notation, we go from left to right. We start out here at negative infinity, comma for all the numbers in between negative infinity and 0. We want this. This is a colored in dot. And when we want that number, which is, and it's colored in like that, we use a bracket because the endpoint is included. So that's the reason for the bracket. Does that make sense? Any questions on that?
And you just ignore the 6 because it's not under the square root, correct?
Absolutely, Alejandro. We're just looking for the domain. We're looking for the set of x's for which the function makes sense. And we can always subtract. We can take any number that we get in here that makes sense for this square root here, whatever that is, as long as it's a real number, we can take that, whatever real number that is, and subtract 6, and we have no problem. So that subtracting 6 isn't going to cause us a problem. Does that make sense?
Yeah.
I think it's a good question. So we covered finding the domain of a square root there. We'll get rid of that. Let's look at the domain and range from the graph of a continuous function. So we're going to look at some graphs here. We looked at those already. So let's take a look at this particular topic. So this topic, domain and range from the graph of a continuous function. The entire graph of the function f is shown in the figure below. Write the domain and range of f using interval notation. So domain is the set of all x's, and y is a set of, so domain is a set of all x's, and range is a set of all y's. So this is definitely something we want to keep in mind here. Going back up to this, what we had on the whiteboard, domain is a set of all x's, range is a set of all y's. I have two different sheets of paper that I used for this, just to demonstrate this to you all, because I thought it would clutter up the graph too much if I did domain and range on the same graphing grid. So we're going to look at the domain first. Now, the graph is this blue graph right here. The graph of the function we are talking about is this blue graph here. So we're going to go from left to right, and we're only going to find the domain this time. The domain set of all x's. So we are looking for the set of all x's here. So we are looking for the set of all x's here. I'm just going to put it x here. So that's what we're looking for. We want to collect all the x's and then write in interval notation. So we go from left to right, keeping in mind the blue graph here. So we're going to start out here at negative infinity, come in, and we want to look for our graph. We want to look for our graph. So we're coming in from negative infinity. Here's our graph. Here's our blue graph. That's the first point on our blue graph, is right here. It's a colored in dot. So we want to include that point. We want to figure out what its x-coordinate is. And to find its x-coordinate, we just need to go straight down to the x-axis, and that x-coordinate is -4. We then just start going back to our graph, going straight down to the x-axis, just picking points, going along. It doesn't matter which ones you pick. You just go down to the x-axis. You want to collect all the x-coordinates of all of these points on the x-axis. So it doesn't matter how many you do, just until you get enough of the sense. You will notice there's a point right at the point on the blue graph, right on the origin, or it's supposed to be right on the origin. So the origin is going to, if you're already, the origin is on the x-axis, so there's no place to really trace down to or up to the x-axis, but the origin is included. And when we get on this side, we then want to get the x's on this side. We go up to the x-axis to get the x-coordinates on this side. We go up, up, up. We get a point on the graph, go up to get the x-coordinate. Go. This is an open circle here. So when we go straight up to the x-axis to find its x-coordinate, we keep that open circle. We don't color it in. So now what I did is I used the purple to collect all of these points on the x-axis. And that's what we are going to use to state our domain. So we come in from the left. The first number that we're going to use is -4. That has a colored in dot. So we need to use a bracket for that. So we have a bracket. The domain is a bracket, -4. And then all the numbers in between -4 and, so all of these numbers, and then we have to stop at 3, but 3 is an open circle. That is not, the endpoint is not included, so we use a parenthesis with that. Does that make sense? So the domain is bracket -4, comma 3, parenthesis. Any questions on finding the domain from the graph? So let's take a look at range on the next page. And you will see, I think I mentioned all of this already. Let's look at the range. And you'll notice that the graph is the same. It's kind of got this curve here, that blue graph. And then we have the same blue graph here. It looks a little different because we're finding the range this time and we're collecting on the y-axis. So the y-axis all the way down in this direction forever and ever and ever is -infinity. So -infinity is way down here forever and ever and ever. Then we go up from -infinity all the way up forever and ever, all the way out to +infinity. So when we collect, take what's on the blue graph and we collect it on the y-axis this time, we start at -infinity down here, and we go up. We look for, there's nothing, no part of the graph here. If we go back or forth, there's no part of the graph here until we get to this open circle, which is not really a part of the graph, but it is important to look at that. And that is open, and we trace that straight over to the y-axis, and so it's still going to be open over here, and it's at -3. And then we take points on the graph, trace them over to the y-axis, collecting them along this y-axis this time. We get to 0s here, and that is on the y-axis, so that's good. And then over here, we're going to trace to the y-axis this direction, collect along the y-axis, and then we get to this colored in dot here, trace it over to the y-axis, and we get that go on the y-axis, that's at 2. And we want it colored in still because it's colored in over here. So now we want to state this in interval notation. So we start with the smallest number first, which is down here. It's at -3. It's not colored in, so we don't use a bracket. We use the other, which is a parenthesis, -3, comma, and then we want all the numbers between -3 and 2. This is a colored in dot, and that's when we use a bracket. So we have 2 here and then a bracket. So that is the range. Parenthesis -3, comma 2, bracket. This comma means all the numbers in between. So the answer is that. Any questions on that for the range? And we can just go back here and just make sure that it is the correct answer. And it was the correct answer. So that's domain and range from the graph of a continuous function. So let's look at graphing in Alex. We'll do a couple graphing problems in Alex. We'll graph an absolute value function and we'll graph a square root function. Let's go up to Alex. Not surprised that it timed out on me, but that's okay. Let's look at some graphing here. Tuesday, Thursday class. Class tools, student view, And I know we reset it last time, so we shouldn't have a problem this time. And we want more on functions. Just going to wait for this to see what this does. And then we want to scroll down, more on functions. And we want to look at graphing an absolute value function. Talked about absolute value functions already in the course, and how when you find the absolute value of a number, you just take and make that number positive. So let's look at this one. This is probably more about showing you how to use the graphing tools as it is about doing the problem. But let's take a look. So this is y equals -3 absolute value of x. So we only have to put 3 different x values in our t-table. And I'm going to go down to the whiteboard here that I'm calling a whiteboard, which is really just a Word document, but it works pretty well. And I want to get a new document. And I want to turn it into landscape mode. So that would be, oops, the layout here. Okay. Landscape. You know, you can see that I'm really pushing the limits of my computer here as much as I can. Okay, so we want to make a t-table. Let me write down the function first. So the function is that we're talking about here is y equals -3 absolute value of x. So this one, they don't give you the directions that perhaps they should. You definitely want to put, when we make a t-table here, here's our x column, here's our y column. And we may need to extend that a little bit. Definitely want to put 0 here, the number 0 in all of these for this particular topic. We want -1 here and +1. That's what I would use for all of these problems. I haven't seen one yet where this does not work. So here what we want to do is we want to put -1 in for x, and then we want to find our y. So we're going to get -3 out in front, absolute value of -1. Absolute value means how many steps do we need to take on the number line to get to the origin. So we're at -1, we need to take 1 step to get to the origin. So what you do is you just take the number in here and make it positive. So this is, there's a -3 out in front. We're going to take the absolute value of -1. That's going to make it +1. And when we multiply that times -3, we're just going to get -3 here for y. If we put in 0, the absolute value of 0, in other words, we make 0 positive, well, we really can't. That's still going to be 0 here. So this whole thing right here is going to be 0. 0 times -3 is 0. If we put 1 here, we get absolute value of 1. Is 1. Because there's only one, an absolute value that is, where you have a positive number, you can just take off those absolute value signs. And when you take off those absolute when you take and find absolute value of 1, you just make that 1 times -3 is -3. So those are our 3 ordered pairs. So let me write down our ordered pairs, -1, -3. So negative parenthesis, -1, -3. Then I'm going to put 0, 0 in parentheses, and then +1, -3. And we'll go back to Alex to draw the graph. So I have been having a little bit of trouble with the pencil tool. Feel free to use it. I'm not very fond of it. I prefer to use the plot a point anywhere tool. So first I'm going to type in -1, -3. And double check it, -1, -3. Good. And then I'm going to plot point. Then 0, 0. Plot. And then 1, -3. And it will look like a V. I mean, it looks like it's for the letter V upside down. In this case, it's upside down. Sometimes it will be right side up. And I'm going to plot. So I'm done with this tool.
I thought for the first or for the last one, it was 1, 3, not 1, -3.
1. Okay, so I got -1, -3.
And 0, 0. And then you put 1 3. And then, but you put.
I'm a little bit confused. So you've got -1,
Oh.
0, 1, and then -3, 0, -3. Okay?
Yeah, never mind.
Okay, that's good. That's the way you learn. Okay, so then this tool is what you're going to use. You want to start at 0 each time with this tool. I'll show you. So this tool is kind of clunky. I'm clicking over the blue dot on 0, and then I'm going to click over one of the other blue dots. It doesn't matter which one you do first. And then I'm going to do this again. I'm going to click at 0, 0, and then click on the other blue dot now. So you should get this V or upside down V, either one when you do these graphs. This is an upside down V-shaped graph, and I'm going to check. Any questions on that topic? So let's take a look at how we're doing on time. Okay, we've got enough time to do one more of these graphing problems. And let's do that. Let's do, oh, let me get that one. I'm just trying to budget my time here and thinking about what the best way to do, what to do. Let's look at graphing a square root function, problem type 1. Let's go back up to the carousel. Right here. Let's see if I can find something a little bit more complicated, but I don't want to spend a lot of time doing it. Let's look at this one. Square root of x plus 4. So f of x equals the square root of x plus 4. So we want to make sure we understand the directions here. Plot 4 points on the graph of the function. The leftmost point and 3 additional points. Then click on the graph of function button. That would be graph of function button right here. Well, let's go down to the desktop here and let's take a look. Now I think I'm going to get another one of these because I don't have enough space here to do it. And I think we're just going to, in lieu of time, we're just going to go use it like this. Okay, so let me just put on in the function, and The most difficult part of this is probably finding the leftmost point. So our function is f of x equals square root of x plus 4. So you find your leftmost point the same way you go about it initially the same way as we went about finding the domain of a square root. You take what's inside the square root and make it greater than or equal to 0. Like that. And you solve for x, just like we did before. We're going to solve for x. So that means we want to move this 4 over to this side. So we're going to subtract 4 from both sides. And then we get x on this side. Plus 4 minus 4 is 0. X plus 0 is x. Greater than or equal to 0 plus a negative 4 is negative 4. And we want to write this from left to right because they're asking you for the leftmost point. So we're going to write this left to right. So this right here, this negative 4, what's the smallest is where this is, this side of it. So this is x is bigger than or equal to negative 4. Or we could write this as negative 4 is less than or equal to x. So the negative 4 is the smallest part. So we have negative 4. I'm going to turn it around and write it this way. And there's no harm in writing it this way to see if it might work. So I want we see what part of the inequality is here. And that would be less than or equal to. Right here that we're going to have. So you see this little v goes to the negative 4 here. This little v goes to the negative 4 here. X. Now, if you look at this from left to right, you go on, imagine a number line, a negative infinity, coming in from negative infinity. Negative 4 is our smallest point, our leftmost point on the number line. So that's what we want. So it said choose the leftmost point and 4 additional points, I believe. So that's what we want to use. So the leftmost point is negative 4. And then 3 additional, we want total of 4 points, I believe. Let me take a quick peek just to make sure. Leftmost point and 3 additional points. So we want 3 additional points. We have to make them, we have to go only in the one direction, otherwise, because of the square root. So we have to add 1 here. That will give us negative 3. Add 1 to negative 3, we get negative 2. Add 1 to negative 2, we get negative 1. So those are our points. And we just plug them in. If I take this negative 4 and plug it in here, negative 4 plus 4 is 0. The square root of 0 is 0. So this is our y column. If we take negative 3 and plug it in here, we get negative 3 plus 4, which is 1. The square root of 1 is 1. If we take negative 2 and plug it in here, we get negative 2 plus 4. That is positive 2. Or you could say this is negative 2 plus 4. That is positive 2. Okay? We get positive 2. And then if we put in -1 here, we get -1 plus 4, which is 3. So those are our ordered pairs that we want to use. -4, 0, -3, 1, -4, 0, -3, 1, -2, 2, and -1, 3. So let's put those in. I'm going to use this tool again. Let's put those in and see if it makes sense to you what this graph looks like. And it's a good idea to have an idea of what the graph looks like. And I think it'll make sense to you when we talk about it. -4, 0. That's our leftmost point. -3, 1. -3, 1. Whoops, I forgot to, there. -3, 1. And I'm double checking. That's good. -2. And then we have a 2. So far, so good. The graph looks good to me, where it's going. Feel good with that. You can check your points on the graph before you click to seal them in. -1, 3. -1, 3 is the last one that we got. -1, 3. Okay. So let's take a look. Let's click on this tool. Whoops, why do we get a, that's not right. Let me see, what did I do? Let me just take a look at this. Square root of, I'm just wondering what I do. Did I not read these numbers right? -4. Okay, well, we're over. We'll look at that topic next time. Sorry about that. I think I made a little error, but I don't want to keep you while I troubleshoot the error. And that's okay. Well, I will take this topic and move it to the next assignment so it's not on what is due on Sunday night. So let me come back to y'all. I'm not sure exactly what I did there, but that certainly is not what it looks like. So that is wrong. Let me come back to y'all and say goodbye to y'all. So I definitely want you to work on the test 1 review no credit assignment if you planned to take the retake. And I would encourage all of you to work on taking the retake unless you're confident that you got a higher score. I will have those tests graded by Monday. For sure, but if I have them graded over the weekend, which I plan to do, but I never know what's going to come up. And Chinese New Year is this weekend, and I have 2 Chinese adopted daughters and also Valentine's Day. So hopefully I'll get your test graded, and I will let you know as soon as I do. And just please work on the test review. If you have any questions, let me know, and I will talk to you all. If you want to get into Teams with me at any time, you feel free to leave the conference, but just one moment. Let me make sure I get attendance. I've got Matthew down, Stephanie Garcia down. Miriam, are you here? Holmes? Miriam Holmes? No? Okay.
Yes, I'm here.
Okay, cool. Honesty Moore? How about Stephanie P? Sailor? No? Okay. And then I've got everyone else. So feel free to leave the conference. And if you want to stick around and talk to me about anything, feel free to do that too. Okay. Take care. Have a good weekend.
Bye. Have a good day.
Yeah, thank you, Alejandro. Austin, do you have a question? Oh, it's the square root. Square root of 0 is 0. And that's the square root of 1 is 1. The square root of 2, negative 2, plus 2, negative 2, plus negative 4 minus 2 is 2, but this should have been the square root of 2. And then square root of 1, square root of 1. That would be square root of 3. Okay, square root of 3. So let's do this one again. Okay. Good. I forgot. Okay. So I need to move these. I need to move this. I forgot. Oh my gosh. I was rushing. Graphing the square root function problem type 1, 4. Okay. And then these two need to get moved. And I don't know where to move them to. Okay. So we're going to have to move them to. Okay. I forgot to put the square roots on this. So it'd be 3, 4, 5, 6. So that would be 0. 4, that's 1 square root of 1 is 1. 5 minus 3. 5 minus 3 is 2, square root of 2. That would be square root of 3. Determine 5 square root of 2. 5, and then what did I do? And then 6 square root of 3. 6 square root of 3. 6 square root of 3. I'm just going to worry about it. Okay, I know I just screwed up. Cool. All right. So I need to move those immediately.